Another draft physics presentation. Okay, we're back on the interferometer. This is probably going to be a long video going through sort of the complexities of what creates the spread of the light versus what creates the pattern of interference style pattern. And it's related to the guy who suggested doing the mirror thing, and the mirror thing isn't, I mean, it seems simple, but it really has to do with particles on the surface of the mirror, which is sort of interesting because in past videos on the interferometer I played a clip from a professor talking about the refraction, internal reflections inside of two pieces of glass placed on top of each other, and how the dust layer creates an unevenness in the surface and would create the interference lines. But the two are completely different functions. I mean, one's causing a skewing, an out of parallel of how the two surfaces meet, and the other one is creating the kind of the double slit phenomenon of the particles are diffracting the light. So this was, no math here, but this is going to get complicated. So the idea is I'll make a video after this for the just with the talking points, the simple things we do know kind of thing, things that can be deduced out of this. And one of the things we've sort of learned is that a single surface creates no interference pattern. It just creates the spread in the light. So the light spreads a lot, but it's a constant beam. And when there's two surfaces, you get the interference pattern. And so in this circumstance, the argument's going to be made that the dust particles are creating mostly uninterfered divergence. And I would argue, because the pattern is always consistent, no matter what the dirty material is, whatever the diffraction gradient is, no matter how you make the diffraction gradient, you always get this same perfectly circular pattern, that it is the glass, the matrix of the glass molecules that's actually creating the pattern, and not interference. So this will take drawings, and I'll read his comments and play this video. So this video basically just illustrates that you can make the pattern go away. Alright, if you have to really, the porch is cold, and so condensation is a real problem. So to keep the pattern really weak, I had to keep cleaning the glass, making sure it was perfectly clean. And it's bad glass anyway, but you can already see the pattern is weaker than it was before. This part I'm just illustrating that you can see the pattern goes from left to right and up and down. The pattern changes from going in to going out. So left, it goes out, turn it right, it goes in, tilt it up, it goes in, tilt it down, it goes out. So that's just a fact. I don't know what exactly it means, but it certainly indicates that this has something to do with the angle of the light reflecting inside of the glass, and not something to do with particles. If it was just the particles creating the pattern, going left to right really shouldn't make any difference, I don't think, logically. So anyway, continuing. So I was trying here to just clean the two pieces of glass as best I could to try to get the pattern to become as minimal as possible. And you can see it's, in some circumstances, it gets pretty faded. So the idea is that if you have the glass perfectly clean, no dust or moisture or anything to create surfaces that the light can be diffracted by, then there's no diffraction, there's no spreading, or very little light gets spread, and therefore there can't be a pattern because no light spread. So without the divergence, there can't be a pattern. Pretty much seems reasonable. So here I'm cleaning it, you can see, And so it just changes things in weird ways. So this square artifact is, I think, something from the laser beam itself. So that's an image of the something within the laser beam that's created that kind of strange pattern. And you can see as it warms up or cools down or whatever it's doing, the pattern does get more intense or less intense. And so now I'm going to spray moisture on the beam itself, and I couldn't create much of a difference in anything by doing that. But theoretically, that's supposed to also, if you can make the room dusty enough, you can also get the pattern. Didn't have any luck with that so far. This is actual water now sprayed onto the mirror, and you don't see it as it really is, but the pattern is really interesting. Lots of effects. So I probably should stop at some point in the interesting effects pattern. So we'll see if we can get some more interesting effects. I think I'm going to clean them off now. So what this reminded me of was the Ken Wheeler's, well, it's not his, the Faro cell. It's just so reminiscent, and I never really thought about light diffracting off the little bits of ferrite, in the Faro fluid, the little tiny metallic bits, and that would create diffraction, and that it could create these patterns. And so it also relates to another optics experiment, the Faro cell. And this is really all about optics. I'm going to argue this is optics physics. It really isn't interference physics. So something else will happen here. So now I'm going to spray the other piece of glass. So I probably will clean this one. I might not clean it, but I don't remember. But you see very little pattern. Just the hint of it's starting to come back there a little bit. It's a little bit of a pattern there if you really look for it. So as it's drying, it's creating particles that are more likely to diffract the light, and so the diffracted pattern is coming back. So there, I've dried it off, and there's still pattern there, but it's much weaker, as you can see. And now I'll probably spray the other mirror. So that was the spraying of the mirror in the middle. This is spraying the mirror at the end, which creates even more of an effect. And so again, this is very reminiscent of the Faro cell in terms of the geometry of the pattern, the way it's moving about. So you can sort of understand that something in a very, very thin film is what the Faro cell is, with particles in it. That's what the Faro cell is doing, is basically creating a distorted view of these rings. So as it dries, you can see that there's points where there's just no pattern because the light just isn't diffracting, because there's not enough little particles or whatever the reason. So I dry it off, and you can see there's no pattern pretty much. So the cleaner the end glass is, kind of decides it more than the other glass, but they're both important. Either one having dirt on it will create the pattern, I'm fairly certain. So just moving it around to see if I can cause anything to happen, and nothing's really happening. So one assumes that both are in a clean enough state where there's no particles to create the diffraction, to create the pattern. And here, so I clean it, and I end up making a pattern. So somehow when I cleaned it, I made it worse rather than better, which, is just how subtle this is in terms of what particles are left on the glass and such. So that's probably enough of the video. Alright, so we'll go to the comments. So I think I've prefaced some of the comments, and we'll see how it goes. So I will jump to here, and I will get this, and there we go. Alright, so this is Hex Hemite or something, not a very good name, but whatever. This will be a long comment. I was the one who suggested this. I suggest this because I achieved the same pattern also. What I found particular, I kind of should have told me that you were setting me up. What I found peculiar was that the rings were not centered on the beam and didn't really know how to explain it. Yes, the fact that the focus of the beam isn't at the focus of the diffraction pattern. But that's the difference is the beam is going straight through where the surface of the glass is creating a diffraction pattern that isn't at any angle. So the diffraction is being created on the surface of the glass where the beam is just going through the glass and being refracted. So the two are in a different location, I think, for that reason. The dirt particles are fixed on the surface of the glass, therefore their refraction is going to be fixed. However, after searching far and wide, I found this a few obscure links and showed the same phenomenon. So yes, this one link was really quite good. I haven't read it all yet, but so it does go into the subject. Yeah, I don't think it has anything stunning in terms of images, so I won't bother opening it. So this was something Newton knew about. So I said pretty much in the video, how could no one have done this before? But it seems really surprising that it's not part of the conversation at all. It's almost like Newton's layers of glass and stuff. There's certain things in physics that they don't pay too much attention to, and they're also very fundamental to this whole idea of quantum mechanics. The answer described by the links is actually really surprising, and I didn't even believe it myself. Yeah, well, I haven't gotten through all of it yet, but they're certainly going to try, no doubt, to create some sort of Huygens explanation, I suppose. But anyway, we'll see. They claim that these rings are an interference phenomena caused by the dust particles on the mirror. I haven't looked at the math and don't think I'll have the time, but it seems to explain why the rings are displaced this awkwardly. Yes, so I think that is correct. I don't have any problem with that. The question's going to be is how you interpret that. So maybe I'll draw this real quick just so we understand some of these basic arguments. So far so good. Actually working. Alright, try not to hit the microphone, Gary. Sorry about the microphone thing. I have to learn not to bang into it. Alright, so single surface creates, so you shoot a beam over it and it creates the line that goes up and down. Okay, but no pattern. Two surfaces will create the beam and it'll have a pattern. Alright, so that's one truth. That's a context here. So I would argue that these dust particles on the surface, these little blobs of moisture or dust or dirt, are just going to be random, and they're not necessarily going to be very, very close to each other. I mean, sometimes they will, and they'll create a diffracted pattern, but most of them are just going to create these straight line patterns. So as a photon hits by one, it does this, it spreads, and if this one spreads this way, and this one spreads that way, and this one spreads that way, and this one spreads that way. And so what all that's doing is just creating the divergence. So the particles are here, the light comes in, and the light leaves spread. But it's not creating rings. Okay, it's just spreading the light. And that's something I noticed. So the light's just a bigger circle. Now that's something I noticed when I had the two mirrors. I'm shooting the laser beam, and it's coming off the mirror, bounces off the mirror. And when I looked at the wall back here, so here's another mirror here, you could see that this light diffracted quite extensively, but it didn't have any pattern. It was just scatter. So it was just a haze of light that was spread. Alright, so that's probably far enough for that, and I'm going to go back to reading. So I just want to point out the thing is, there's one thing that causes spread and then we have to come on, I think it's a different explanation for what's causing the pattern. So I guess I should just get to the different explanation. It's verified by the, like I said, there's this experiment you do with that I showed in a previous video, where you just put two pieces of glass on top of each other, lenses. I mean, not focal lenses, just two heavy pieces of glass. And what happens is the little tiny particles of dust make these line up a little bit unevenly. And that little bit of unevenness creates a light and dark pattern. They'll go across the top of the lens. So the top of the lens will have that pattern right across it, indicating that this is, again, a phenomenon about surfaces. In this case, the light comes in at different angles. It can come in straight or it can come in at an angle. If it comes in at an angle, it's going to refract and it's going to keep internally reflecting. And I'm arguing that these internal reflections are the things that are creating the bands. So the rings are being created by the points where the light reflects back out of the thin film or the glass surface, however you want to calculate it. It's always about surfaces that are meeting, so two different indexes. The transitions, however you want to describe it. And that so the diffraction, the spreading, is being caused by the particles. They're, in a sense, scattering the light, spreading it. And then the glass, is the one that's creating the pattern, because it only reflects, the light either goes through or reflects, because the light itself is a grid work. It's a bunch of, you could say tunnels or bands, but there are, because of the surface of the light and how the molecules line up, so you got to think the little atoms are like this, and they're lined up kitty corner to each other, so they can't line up on the surface evenly. So the surface of glass is not an even surface, even when it's highly polished, because the atoms are out of phase with each other. I should have drawn that much bigger. So it's this idea. The atoms are lined up next to each other in a geometry that means they're not in phase. Okay, so these pockets are what are creating, this is where the light is transmitted through the glass, this is where the light is reflected off the glass. And so that's what makes it so important, what angle you turn the glass at, or how deep you push into a pattern. So if a pattern is coming at you that's going, that's spreading, diverging, and then you go into a matrix like this, a jagged line, you could sort of understand that as you move this line in, where this hits changes. So this beam here hits and go through her, and if I just move it a little bit, it hits the peak, and it's a reflect. And if I move it a little further, and it goes back in, I move it a little further, it reflects. So it's the divergence, the non-parallelness of the light, that is creating the effect that any surface that has a pattern in it, the pattern will repeat as you move through the diverging light. So I think that's this is the real cause of the pattern. And I'll try to prove that or emphasize that and try to explain that that's the key to understanding what's happening here. The particles are causing the divergence. The structure of the glass is creating the pattern. That's why the patterns always look so much alike, no matter how they're formed, no matter whether it's dust or whether it's moisture, whatever the cause of the diffraction, the pattern is always the same. Same pattern, whether I use water molecule droplets or whether I use chalk dust, doesn't matter. I'll get the same pattern. So the pattern's in the glass, and the diffraction is caused by the particles. no interference required. Is the point. Alright, I claim that these rings are not, let's see, the answer describes, okay. I claim that these rings are not interference phenomena caused by the dust particles on the mirror. Again, the diffraction, the spreading, is being caused by the dust. I haven't looked at it's scattering. The dust is scattering, spreading, to put it simply. I haven't looked into the math and don't think I'll have time, okay. To actually see if this is plausible, I decided to do the experiment with my own mirror. Number one, in the first case, I cleaned the mirror to make sure almost nothing was on it. You have to make sure nothing is on it. I took my vacuum cleaner, so in the second case, and dumped whatever fine particles were in the vacuum bin onto the mirror. Yeah, water's a little cleaner. Anyway, just, FYI. In number one, I did not see the rings, and number two, the rings were actually much more visible and consistent than the first time I saw them. I haven't seen them ever be inconsistent. So, you've seen the video. I mean, they're the same every time I do it. It doesn't matter what I do, they're always the same rings. This is exactly what's expected based on the links, much to my own very surprise. The dust actually changes, creates the rings. No, it creates the spreading of the light. Okay, I don't know if the same will occur in your case, but just remember, like the single razor blade. When I shot the light over the edge of it, the spread was 2-3 feet high at 1.5 meters. Tiny bit of distance, huge, gigantic spreading of the light. So that's how much spread you're getting from these little particles of dust are spreading the light. Huge amounts, potentially. Okay, I don't know if the same will occur in your case, but this is what I managed to get. Also, I don't fully understand the phenomenon myself, but we'll try to study it if I have time to see if it actually makes sense. Yeah, I appreciate your input. This was great stuff. I mean, I would not have... Who knows if I would have noticed it eventually. I don't know if I would have done the experiment, but yes, it didn't occur to me. I looked at the mirror, it looked clean to me. So I had no idea that little bit of condensation, because it's 50 degrees out there, was enough to create such a bright pattern. Alright, I hate to say it, but the pattern isn't the Michelson-Morley pattern, or at least it's not the same situation. Well, you think so. I'm saying I don't know how you can even, I don't know how you argue that, actually. Oh, sorry, I'm not on the right window, so I will take this opportunity to bring this window back up and say I just don't know how you can't say that's not the Michelson-Morley pattern. It's exactly the pattern you see with every interferometer. And as I pointed out, as you move it, you can see it cycle in and cycle out. So it's exactly the same pattern. I don't know. I just don't know where you got this impression that it's not the same pattern. I can't see how it's not. It's so identical. You can call it identical. I mean, I don't think there's any variance from identical at all. So I don't know what to say to that comment. I just don't know where you got that from. Alright, the problem with all these interference experiments is that the two beams need to be very, very well aligned. Well, says you. I don't know. We are dealing with 500 nanometer wavelengths. Well, in this case, more like 350 or 390. But anyway, so, well, no, I guess it is 500 for green. So in order to maximize those fringes, you need the beams to be aligned to within 1/10 of a degree or so. Otherwise, they are too small to see. Well, again, the point is that you're using the diffraction gradient. See, look, I made this argument 2 months ago or something, 3 months ago. I pointed out how the beam splitter is relying on essentially creating a diffraction gradient in the path of the beam. So a half-silvered mirror, for example, is a bunch of holes. A bunch of 2 slit experiments or 1 slit experiments, however you want to look at it. But it's a bunch of experiments where light is diffracted. So the point is no matter how big the hole, you make the holes really big, you'll get spread on the edges, but the smaller they are, the more spread you're going to get. So obviously the smaller the scrapings, the finer they are in terms of the removal of the silvering, the more diffraction you're going to get. And I pointed that out. I said the beam that goes through the beam splitter has to go through the little holes in the silver, which means it's going to get spread. And the beam that doesn't go through the holes doesn't get diffracted and doesn't spread. So the two paths right from the start, the light isn't the same here as the light is here. The beam that goes through is spreading. The beam that doesn't go through isn't spreading, and doesn't get spread till it comes back for the last leg where it goes through the holes. So going through the holes of your diffraction gradient or your beam splitter, and all the beam splitters one way or another are sort of relying on that phenomenon, that's your answer in my opinion. Okay. Let's see, 1/10 of a degree or so, otherwise they're too small to see. This is why people talk about double slit so much. They talk about it because it's easy to create and the two outcoming beams are aligned automatically. Otherwise you need somewhat expensive precision tools. So again, I don't think that's true. None of the interferometers I've even seen are that precise. You always have to align them up by eye. So I don't buy the argument really. This is why Hathaway probably did not achieve making the pattern if he even attempted to create them with his beam splitter. Yes, well obviously he decided to no longer participate after purchasing said cube splitter. So his type would be two of these glued to each other. So that's the traditional, the most used kind of is these cube style. And what the glue is actually the particulates. So it's just like blowing on it and then sticking the two together. You're creating little particles, sticking the two together. This becomes the diffuser, which the diffraction gradient, and this spreads the light. So the beam that goes, comes in and goes through gets spread. The beam that reflects off doesn't spread. I think that's pretty solid. All right. Let's see. There are also possible issues with the fact that home mirrors aren't designed to reflect lasers. Well, I don't think any mirror is designed for it, so they may have multiple layers giving internal reflection. I think internal reflection is inevitable because of the angle. Okay, so even in the cube, they're relying on this 45-degree angle. Okay, this 45-degree angle is what's changing the direction of the light. And once you have that 45-degree angle, as I've already shown, you're already splitting the light 50-50 just with that angle. That's all you need, just a piece of glass at that angle, and you're going to get 50% and 50%, which means the internal reflections are going to be obeying the same rule. They're still reflecting at the 45-degree angle internally.
Could be a new post.
And therefore they're just going to keep reflecting and reflecting and reflecting internally. Alright. At a high rate, because it's 50. Instead of being only 4% reflection, 50% is a lot more than 4%. So you can understand that, if your light comes in straight, it's only going to be a 4% reflecting. But if it comes in at an angle, the reflective index goes way up. Okay, so there's a possible issue with, multiple layers. When I shine a laser on my bathroom mirror, I get a row of beams because of that. Understood. I don't think I opened this. Some sort of PDF link. I guess it's not going to be his mirror. Oh, LIGO. This is so funny. Well, I don't think it's their official site. I don't think that would. Maybe it is. LIGO.org. Oh man. I wonder how many lies and bullshit they have in here. So anyway, yeah, that'll be quite interesting. I'll have to definitely read this. Yeah, definitely. Okay. Alright. I'll save that for later. Okay, so I do have the right window open, correct? Yes, pretty much. Alright, so we will jump to, let's see if there was any other snarkyisms or something. I'll deal with other comments later. I mean, this guy's comment's sort of related, but it's not really. It's on the two slit. The strange thing about the experiment is the pattern of interference is horizontal. Yeah, well, it's only horizontal because that's where the two, it goes in both directions. So if you have a square slit instead of a rectangle slit, instead of a tall slit, you'll get pattern going both directions. So there's nothing, it's not inherently horizontal. It's just being diffracted at the surface the greatest amount because of it has more length this way than it does this way. So obviously you see it more on the longer side. So I don't think we need to go into that. I think he has a wrong premise. Alright, so block me, bitch. Okay, which I will do, asshole. Alright, so my question to you is, I personally have seen videos of interferometers, so have I, and I have actually seen with my own eyes the length of the leg being adjusted, so have I. I saw that the resulting fringe pattern changes with each turn of the knob. Yes, because know what you're doing? See, unlike the experiment I did on my porch, alright, maybe I'll draw this. I'll show you the critical difference between the two experiments and why my interferometer won't work like theirs unless I set it up to work like theirs with changing one feature. Alright. So when I'm doing the experiment, and when I'm getting my patterns being created, as I think we can say with quite a bit of confidence, is because the piece of glass has particles on it. Okay, and it's this piece. It's the piece that's not the reflecting piece. So the beam's coming in, it's hitting the particles here, and then spreading. Where in the traditional interferometer, the layer that has the particles is here, and it only works in one direction. So the direction that reflects doesn't get any spread, so there's no spread this way. The direction that goes through, this is the direction going through the holes, the unsilvered mirror. Okay, these are the ones spreading, the ones that go through the holes in the mirror. This is the beam spread, and they're adjusting that beam. This is their adjustable mirror. So they're changing the distance essentially between the angle of the light and the diffraction gradient. If you can understand what I'm saying. This beam is going to go out and then come back, and it spreads even more as it comes back. But I think that's right. This is the target where it comes out. So yeah, they traditionally move this mirror. Yeah, that's right. So anyway, so that's the one. So the distance, they can control the distance between the reflection and this. I can't control the distance between these particles and the reflective surface, where they can. So that's the difference. So mine, tilting it makes a huge difference. Tilting it this way makes it move. Moving it in and out doesn't do as much. So because I can't change the distance between these particles and this reflective surface. You get that? Maybe. If there's any hope you got understood? Yeah, any hope. Alright, so we'll go back to the comment. The rude comment. Unnecessarily rude commenter. Alright. Being adjusted. I saw that the resulting fringe pattern changes with each turn of the knob that adjusts the length. Okay, so as I'm explained, you're changing the distance between the reflective surface and the particles, where I don't have that luxury. All right. So I'm supposed to forget that interferometers do this. No, the whole point of the conversation, which you don't seem to get, is I'm not contending interferometers can't be incredibly sensitive. I am arguing that I don't believe they're distinguishing between a quarter or an eighth or a 100th of the wavelength of light. So I don't think they're detecting 25 nanometer movements in distance. So I don't think there's any hope that they're doing that. That's my argument. That there's a physical phenomenon that explains what's happening is my argument. Why the instrument is sensitive. And as I pointed out, especially with diverging light, the greater the distance, the more the divergence, the more compounded it's going to be by the reflective index of the mirror. The more difference between two little beams, how much they're going to differ in their path is going to be huge, because they're going to reflect at a completely different angle on the glass surface, resulting in something you can measure. It's like the giant shadow thing in a way. It's just another way. It's another kind of microscope. Now, if I can use that term. It's a way of magnifying a little change in one place and making it look big somewhere else. Alright. Resulting in fringe pattern changes with each turn. Okay. So I'm supposed to forget interferometers do this. No, exactly. It's nowhere in my comments, nowhere in anything I've said do I deny that interferometers are sensitive devices. I'm arguing with what they think is the cause of the phenomenon and what they state it to be capable of doing, which is measuring phase differences in light beams, which I don't even think is possible. Tiny phase difference in two photons can't even be done. I contend lasers can't even produce perfectly coherent light, that is, all the light in phase. So I'm saying that there's nothing theoretical, that this experiment is premised on theoretical circumstances that I don't even think can exist, let alone cause what they think is happening. I'm saying their explanation of the cause is incorrect. Do you get it? I am talking about causes, just like Einstein. I'm not denying the existence of the inverse square law. I'm denying that the inverse square law creates a well in space somewhere. Okay. So I'm supposed to forget that interferometers do this just because you saw just because I saw your video. No, it's not just because you saw the video, because I made arguments in the video explaining like 3 months ago where I pointed out that, look, if you're going to half silver a mirror, it means you're going to create a lot of interference pattern, because clearly the light going through the holes, it's just like going through double slit experiments. It's just like going through a diffraction gradient, and the ones that reflect will not be affected. You don't think that's an interesting fact, or a fact worthy of consideration, that the two paths of light will be fundamentally different? The ones that go through the two slits and the light that bounces off the slits are going to be fundamentally different light? You can't understand that argument? If I made two chrome slits, and you watch the light that shines onto the slits and the light that bounces off the chrome is one kind of light, and the light that goes through the slits is spread. You can't understand that it's, yeah, I can sort of understand that the light that hits the chrome doesn't get diffracted, it just comes straight back. And the light that goes through the holes is going to get diffracted and create patterns. And so the two beams, the one coming off the reflected chrome and the one going through the slits, are not going to be the same beam. You can't understand that argument? Okay. Saw your video. I'm now supposed to develop amnesia. So again, just more rhetoric that has nothing to do with an argument I've made. I haven't made any argument that you have to have amnesia. I'm making an argument about their description of a cause. I'm saying you have to be critical thinker and say to yourself, okay, let's examine this Huygens explanation compared to some other explanation where, let's say, electrons are causing the problem. That's what I'm asking you to do. And forget everything else I happen to know about interferometry. Right, so what do you know? Oh, you saw a pattern come out. It's essentially what you're telling me. What do you know about the reflective indexes of the glass? What do you know about internal reflections? What do you know about any of the mechanics, physical mechanics of the experiment? What do you know about those things? I'm asking you to ask yourself, do you think you know enough to say, I'm sure it happens the way they say? I'm sure of it. Do you have enough knowledge to be able to say that with any credibility at all? That's what I'm asking you. It's obvious that you're not being careful with your experiments. And again, it's obvious that I'm videotaping them and showing them and in no way highlighting or distorting or fiddling with them to make them do something in particular and then not showing something else. The videotape runs and I play around. How exactly, and again, beyond what purpose do I have to be careful beyond pointing out, yeah, look, see, I have a broken piece of mirror glued to that can. You know, do I need to do it some other way? I don't think so. Anyway, careful with your experiments and proves to me that you have no interest in the truth. Okay, because I don't have an expense budget in a laboratory, therefore, you know, I'm casually disregarding some ethics of physics or science. It's just such a pile of crap. I'm sure that, you know, Newton didn't have a pristine laboratory. I mean, you're just being such a cunt. You know, this is a useless argument. Again, if I was somehow just highlighting little pieces and, you know, showing things in distorted way, then you might have an argument. But there's no evidence I've done any of that. So this is just such a bullshit accusation. And that proves to me that you have no interest in the truth, even though you say you do, and complain loudly that actual scientists do not. I haven't complained that they have no interest. I'm saying clearly the talking heads of science are pageanters. Okay, they're pantomime horses. They don't have really any interest in the truth. They've never even touched any of the real materials. I mean, somebody mentions here Feynman again, so I'll you know what he says, Feynman's glass experiments. Feynman never did a glass experiment. Feynman in a video reveals that he never even touched a photomultiplier. Okay, he didn't go anywhere near any of these experiments. These are all just things he assumes to be the truth. The results are the results, and he never touched any of this shit in his life. Okay, but it's obvious, or it should be obvious to everyone here, that you are the one not giving a shit. Well, like I said, it's clear to everyone here, should be clear to everyone here, that I've shown over and over and over again, thousands, you know, hundreds, dozens of two-slit experiments and explanations, and every single one of them has the lie that, look, you cover one of the slits and just a lump of light comes out. Every one of them has that casual disregard for the truth in it. Okay, from Jim Al-Kahari to all the talking heads, not one of them has ever explained the two-slit experiment accurately. Not a single one of them. And if you can show me a single talking head who has ever explained the two-slit experiment accurately, then I'll give you some sort of credit. But you won't be able to find a single solitary description by a talking head scientist that's come anywhere close to the actual fucking experiment. So who's the liar? Who's defending the lies? Who's defending the bad science? You're the bad scientist defending bad scientists. Period. Bitch. So, yes, I'll go about the business of blocking you, fuckhead. Rude fuckhead. Jeez, okay. So this is the guy who brought up Feynman. So, sort of good timing. Nice experiments. When I talked about Feynman's QED, so again, there is no Feynman QED that I could find. There's different books Feynman's written, and they have titles. Now, the QED thing, Quantum Electrodynamics, was a series of lectures in Auckland. I've said it 4,000 times. I saw all of them. I saw all of the 1960 whatever lectures by Feynman, and all of the 1980 ones, and then the ones at some whatever retreat in California, where he mostly talked about nanotechnology and it was kind of boring. I meant the importance of his experimenting with light passing through glass. So see, he has this impression that Feynman did some experiments with glass. Feynman never touched a piece of experimental glass. Never, ever, ever happened. Okay? He's just reciting what Newton discovered 300 years ago. Glass can have 16 different thicknesses. Now it can have an infinite number, well, almost. We can have a lot of different thicknesses. It's just that certain thicknesses will end up with the same result. So, you have to get to a certain degree of thickness before you change the effect. And as I pointed out with the molecules of the alignment of the atoms on the surface of the glass. So you're just basically saying that they're like little magnets, these rows of atoms inside of glass, and they move this way, next to each other. So they have to be off phase. And the point is you can have them get closer and closer and closer, and then it breaks down, and then this one switches. So it gets closer and closer, closer, switches. Closer and closer, switches. So it's like little magnets, and there's a point where they have to go back to cycle back to zero. And that's the surface changes. So as you polish the glass, you try to even the atoms on the surface. They'll allow you to even them a little bit, but when you get to a certain point, they magnetically can't do that, like magnets, and they flip. And the atom flies off the top, or the other one sinks down. Something has to change, but they have to regain their geometric balance. Alright, the 17th thickness gives the same result as thickness 1. Again, it's just a cycling of change and then go back to 0. Change, go back to 0. Change, go back to 0. QED also means quad et demonstratium. Who cares? But the book is about quantum electrodynamics, photon quanti. Again, I don't need this bullshit. Frankly, I've said it already. I said it in the video previously. I've watched every single one of the lectures, and the lectures are the only thing in the damn book. I mean, reading a book of lectures, in my opinion, that you've already seen is kind of retarded. The book is referenced as being the Bible of modern physics. And again, it has errors in it that I've already pointed out, but okay. Feynman explicitly says in that book that photons are particles. He says, I wish I could undo everybody's education and, where they have this stupid wave notion. He says basically they're particles. Okay, and yes, they do a wavy thing. Richard Feynman is referenced as being the most important physicist of the 20th century. Well, is that supposed to impress somebody? Sorry, it doesn't impress me. Okay, so, the Pope endorsed him, that kind of thing. Everybody thinks a lot of these people are really significant people. Hawkins and the guy in California, Stanford, whatever his name is, and with his holographic nonsense. I mean, it's babble. I say all this because you were talking of rolling electrons bending the photons in the slit. Again, I don't really understand. I wasn't really talking about them rolling. I don't know where you got that from. But I was talking about the fact that they don't move straight, and because they're under pressure. And when they release a photon, that is when they give back the energy, the momentum, when they rubber band, they release the photon at a new vector. That's what I've said. Alright, so Hexa may meet again. Alright, you said that you wanted a conversation, so I'm hoping this could count as a resolute discussion. I don't know. If we're going to have a resolute discussion, I don't even know what that is. I hope you can at least try to present the ideas you don't like in a fair way. Well, again, I wish you could at least refrain from some sort of snarkyism that serves no fucking purpose. Now, you want to say that there's something I have mischaracterized, go ahead and make the direct accusation, and I'll defend myself against it, because I don't think I've mischaracterized a single one of their wacky, silly, insipid ideas. So, fuck you. I say this because this is the thing about Huygens. So this is the thing you say about Huygens. Professor Lewin thinks it's a real thing. So you want to pretend Huygens isn't real? Fine. But physics professors are teaching it as if this is how it physically works. So to play this game that Huygens is just math, first off, Huygens isn't even math. There is no Huygens math. Huygens creates a geometry that creates an angle. Okay, and the angle is put in the math. So Huygens isn't math. All right, Huygens is, so he puts this in bold, and I'm going to say, well, you quit mischaracterizing the truth, because this isn't the truth. Huygens is not a mechanism. Well, first off, bullshit. It's at the very core of wave-particle duality. And if you think duality makes any sense, I think you're an idiot, but whatever, that's my opinion, okay? If somebody thinks duality is what really exists in the universe, some sort of fucking particle that's also a water wave or a this wave or a that wave, I think that's just fucking retarded. But whatever. Huygens is not a mechanism. It is only a mathematical way to analyze the wave equation. Well, it's just you're totally wrong. It's the way they premise the wave equation. It's the premise they rely on to create the phenomenon that creates the sine theta. They have no variable without their Huygens. They have no source of the variable. They have no source of their angle to multiply on their nodes. They have no math that works without their fake Huygens to create the angle. So to say it's mathematical is just nonsense. It's pre-math. It's a premise for a variable. It's a defined cause. I mean, this is like saying Einstein doesn't mean that he thinks space contracts or that he thinks space is warped. Of course he does. Okay, it is not fair to say that people are saying that there are infinitely many waves being created in a physical sense. Again, there's absolutely no other way to argue this. They're citing it as a cause of the phenomenon. Now, if they want to admit their cause is fallacious and made up, okay, fine. But do you think they're doing that with dark energy? Do you think they're doing that with dark matter? Are they doing that with bent space? Are they doing that with any of the virtual photon? No, they're saying these are real things. You know, keep pretending that this is just some sort of, we're not really defining causes, when all of their causes are all based on wave phenomenon. Every single one of them. Come on. Because instead it talks about how to deconstruct the math. Well, again, the math doesn't have Huygens in it. So this is just bullshit to say there's Huygens in the math. There is no Huygens in the math. There's algebra you do before you do your math. And that's Huygens. The primary tenet of the theory always is wave equation, not Huygens. Well, again, you can't have the wave equation without a cause for your variable. So again, where do you get your sine theta? Where I'm saying the sine theta comes from the movement of the electrons. Can't you see? I'm using exactly your math, even though I don't think it's accurate enough. And I'm saying, yeah, okay, you say Huygens causes sine theta, I say electrons cause sine theta. That's the difference, jackass, or fuckhead. I mean, look, I'm just saying, you're going to give me this rude crap, I'm going to give you rude crap back. But again, there's an example. So you think I have been unfair to Huygens, which I think is an outrageous statement when it's always brought up in every physics lectures at MIT, physics lectures at Yale, physics lectures at Stanford. They all use it, and they all talk as if it's a real effect. So to pretend to me that they really concede it's just made up and it's just a placeholder for the truth, they never say, Huygens is just a placeholder for the truth until we find the real cause. They never say that, ever. Okay. Look, I mean, I play a clip of Professor Lewin. He's reading somebody else saying, you know, some commentator saying, this Huygens nonsense that has absolutely no proof that it exists, absolutely no reason to apply it as a real effect, no evidence whatsoever, and the guy basically says, you people are getting the right answer for the wrong reasons. And Professor Lewin basically says, well, I'm going to just continue to get the right answers for the wrong reasons. So, I mean, he's quite convinced Huygens, because he was Dutch, is a real thing. Alright. Great clockmaker, but yeah, fucking asshole. I hate Huygens. Just like I said, there's lots to admire about him, but I mean, this stupid wave crap has ruined physics. Alright, now speaking of how the wave equation behaves, you can see the app to simulate it. Well, I saw some of your images are unresolvably, you know, tiny and useless, but whatever. But yes, so well, I'll get to the one that's just really easy to point out how this guy isn't exactly he's not making a straight up fair argument here. You can create your own custom setup if you want, and you need fairly high frequency waves before you get anything intelligible. Yeah, isn't that evidence of something? Yeah, you have to keep making, you have to agitate the water more and more and more. Why is that? Because, oh yeah, you might create more interference that way to shove through the opening. For example, I made this image. Oh, okay, we'll look at your image. I'm doubting it's something he did. Oh, okay, this isn't a real thing of any kind. So, and again, so this is his evidence of an interference pattern. Two diffractions. And I would argue that that's just diffraction. Sorry, that's not an interference pattern. All right, that's just the fact that water bends around surfaces. So yes, water will bend around surfaces, but this isn't anything like the single slit in light. The single slit in light can create 100, well, let's say 80. I've seen them with at least 80 lines. Show me a single slit in water creating 80 lines. No, it's not gonna, you won't do that, of course, because it's impossible to do. Right, so then he says here, which really pissed me off. Previously you complained that all the water videos had non-uniformities before the slits. Yes, they do. I didn't complain about something that wasn't true. I complained about something that was actually true. Okay, the ones that actually created any kind of diffraction, that is a number of minima and maxima, the ones that actually created minima, more than one or two, yes, they had to agitate the fuck out of the water. Now that's a fact. Now, not a lie. That's a fact. I will concede, if it's worth anything, that a proper demonstration is hard to achieve. Again, a proper what? A proper jigging and rigging of the experiment. Instead of just doing it honestly and saying, what happens when I drop a drop of water into a puddle? Oh yeah, there is no interference. The water just spirals out. No interference whatsoever. And if I do it with 2 drops of water, I get interference. That's the honest way to do the experiment if you want to actually understand the difference between diffraction and interference. Because in water, of course, the water sticks to the surfaces and some of the water will be bent. But it's not being bent by the same mechanism that you would imply to exist in the light experiment. It's clearly just being bent by friction. Alright, that's fair enough, but what about this? So I don't even know why he posted a link to this video, because it demonstrates my point, not his point. So it's just imagine, where's the problem there? The problem is you haven't demonstrated any kind of interference at all. That's the problem. And it's not in English, which is also a problem. But it doesn't matter. So, it should be playing, right? Yeah, okay. Good enough. So, they're mostly flat waves they're showing. Okay. They're not exactly perfect, but close enough. So, yes, then we start with little slit. Okay, a little bit, don't really need that part. Alright, so he says, look at that, look at all that interference. No, it's the same pattern you always get. Yes, you'll always have some break off the surfaces because the water sticks to the surfaces and bends. So all you have is the 2 surfaces are creating one diffraction each, and then the rest of the water is completely going down the middle. There's no pattern here. There's no interference pattern here at all. Clearly, even less interference. Again, just the same little periphery. That's it. Most of it straight right through. That doesn't look anything like the single slit in light. Nothing like it. So neither one of these examples, wide opening should be giving you a huge number, right? The wide opening gives you the most pattern in the single slit, without going too wide, of course. But, the more narrow you get, the crappier your pattern. The wider you go, the bigger, better, more lines in your pattern. You see that here at all? No, you see less, not more. Less, a lot less. We got the double slit coming up now. Don't really need all of this part here. It's kind of just a little bit. You just hear that part. Alright. It's not even much of a pattern here even with the double slit. So, but at least you have something. But you can see, look, these lines are getting a little lumpy here. But regardless. Not much of a pattern by comparison. So nothing to really explain here, right? There's interference here because the two round waves get to each other and interfere. In the single slit, there was nothing got to the middle wave. There was no interference, and the two periphery waves were so weak they couldn't create any more interference, and they were going the wrong direction. So I'm just saying this proves my point. I don't see anything here to explain. Completely validates what I'm saying. Single slits in water have nothing to do with single slits in light. There's just absolutely nothing to compare. The only thing a single slit does in water, just like dropping a drop of water into a puddle, into a pond, there's circular waves, there's no opportunity for interference because there's nothing to break waves. Alright, so I think that's enough of that one then. Okay, good. So we're moving right along here. Right, I read both of those? No, I guess I only read one of them. I read this one. Alright. You mentioned that the double slit pattern is a bar pattern. I agree that it looks like a bar pattern no matter how hard you squint, but I dispute that you're getting an accurate representation. So maybe he's the same guy that was doing all that ragging about this stupid, you gotta use photo detectors or something. I mean, this is just, look, you don't want to concede the point, don't concede it. I don't care. I just really don't care enough to sit there and have to sit there and prove to you that I can show you every single experiment ever done with light and it looks nothing like the ones done with electrons. So I'm just saying, if you can't see the huge gigantic difference between the two patterns, fine, whatever, we're done. I don't want to spend I don't want to spend years having to, you know, prove a simple point that, look, I did the pattern on my own damn porch, you can see what it looks like. So anyway, there's at least one person who looked at this, and again, this wasn't again, I'll show this, and it's, you know, just, sorry, not terribly useful. In terms of actually, you know, it shows its own face, you know, complex experiment, you know, and you know, there's, like I said, nice drawings, but where's the results? And this chart he shows doesn't even make any sense. Yeah, because he shows another illustration of it. This is where they have the marks. There's just as many marks here at the bottom as there are marks here at the top, which doesn't make any sense. How could this be that's supposed to be a black? The down things are supposed to be nothing, not something. So I couldn't even read the chart. Yeah, and you say there's proof here that there's a nice gradation between all the bars. The bars peak at a nice bright spot and then go down to a dark spot in a perfect sine wave. This is not evidence of that. So I just, you know, no. Sorry. But I'm not going through that whole entire page for this point. If you can't concede the point, fine. We're just done with that whole conversation then. Fine. You don't see it as a reasonable bit of evidence that there's a stark difference between the pattern in electrons and the pattern in photons. Okay, forget it. We just can't have the conversation because, yeah, I'm not going to spend my life proving it. Basically, there are two things done. For the first part, you can use a laser and you can use a photodiode. Again, why wouldn't you just use a photo multiplier then? And look, and see, it says it right here. A photodiode that has a pinhole to record the intensity at various locations. We've just demonstrated how you can't do that. You can't make a pinhole because it diffracts the light. It spreads the light. The light won't go in the right direction. How can you do that? Alright, anyway. For the record, for the second part, you can use a single photon source and a CCD camera to detect photons at various locations. Yeah, I'm not saying you can't. I'm just saying you think there's reason to. I think there's no reason to have to go bother doing any of that, because the light has been shown on so many different kinds of surfaces, and I think you're just deluding yourself if you're saying we can't see it and we can't photograph it as it really is, but somehow when it's electrons we can. This is probably better because it could get rid of various worries you might have with photodiodes. My only worry with photodiodes is they're huge, and so that's not going to do you any good. And the smaller you try to look again, I mean, this is you're using the very thing that creates the phenomenon to try to measure the phenomenon. So it's like when they use the pinhole to create the light that goes to the two-slit experiment. There is a certain logical disconnect, isn't there? Like, we know that diffracts the light, and we know in the course of that diffraction, if that hole is small enough, that small aperture, that it will create Newton's rings. And so you're shooting Newton's rings into the two-slit experiment. You can't see how you break your experiment by trying to use instrumentality that interferes with your experiment. Okay. Anyways, this is what's shown on the site. So this, I think, is this is a pitiful chart. Okay, yeah. So there's just no way to read this chart. So he links this. This is what's shown. You can't decipher this at all. So the round dots are supposed to be both slits open. Why is there a bunch of dots here at the bottom? I don't understand that. Why is there a whole bunch of dots where it's supposed to be no light? And these little arrows here, this is one slit open. How do you read this? I'm sorry, this is an unreadable chart. Okay, forget it. Not useful. Alright. No, we're done with that, I think. Let's see. For the double slit, it's even for the single slit, you can see the photon count is exactly what's expected. Well, it says you. This is the real experiment done by this guy. I don't buy it. I've seen the experiment. I've done the experiment. No, whatever. There isn't much more info, but it's worth looking into this. You say it's worth it. I say it's quite obvious that the patterns are quite different. Photons and electrons, quite obviously different. Alright, so I guess I'll read this first since he's replying to his own comment. Alright, so I think this is getting there. If you're right, there are a few questions that would be necessary. In the previous video, you proposed an experiment that could decide between the two contested models, which requires you to shoot a tiny image right between the two slits. If the electrons are there, the copy should be formed anyways. Yes, the point is that the photons go from position. It's not probability, like wherever you go inside the slit, you go to any kind of direction. No, the ones that go near the surface bend. The ones that don't go near the surface don't get bent as much. That's the reality. So yes, any image will be somewhat diminished because they're going to hit more or less electrons. There's no perfection in it. But yes, basically the image would be moved to all the locations. But the problem is it's pretty hard to create an image this small. Alright, anyway, which requires you to shoot a tiny image right between the slits. If the electrons are there, the copy should be formed anyway. Well, obviously you have to shoot the image bigger than the slit, because you have to go near the surface to create multiple images. There is a plausible processor to this experiment that can be done. You can shoot your beam, but shoot it at the edge so most of it is blocked and only a tiny sliver of the beam gets through the slit from one of the edges. Yeah, so I've done it. Maybe I should video it. Just fiddling around. I mean, I'd like to find a real precise way to get the beam to move just a tiny bit at a time to do it really well. But I did find that as the beam encroaches, it creates a much bigger pattern. The pattern has bigger bars, and then as you move in, the bars get small. I did notice that. What should happen is something like edge diffraction. So there is possibly what should happen is something like edge diffraction, so there is a possibility you will see the pattern. Well, you do see it, where if it was just a single razor blade with no slit, then I would expect to see no pattern, just diffraction. But I did see pattern, so it sort of indicates that yes, the proximity of the objects is causing the pattern. The objects being close to each other are changing the surfaces a little bit. Alright, let's see. However, the question is, does the pattern depend on the width of the slit whenever the beam is not touching the other edge? Well, it is a question about how much of this is interfered with by the beam actually hitting the material, exciting it. There could be lots of arguments that we're not noticing in terms of there's energy going into the system, not just the photons that go through the slits, and that energy could be affecting something that would be a surface phenomenon. So if I'm right that the surfaces are causing the phenomenon, it would be perfectly reasonable to speculate that there's going to be some effect from the energy of the beam itself hitting the material. Alright, you say something like the pattern is formed by the edges. The pattern is formed by the edges. I say the pattern is being formed by the electrons, and that at different positions between the two slits there are more electrons and less electrons, and therefore you will be diffracted by your likelihood of being diffracted increases the closer you are to a surface, and you're less likely to get diffracted the more towards the center you are. That would be the theory. So if the beam is touching only one of the edges, it should still be creating the same pattern. Well, it's not the same, but it's a pattern. So it starts off like big blocks, and then as you move further in, they go small again. But there is a pattern. And that pattern should depend on the slit width. Right. Well, it can't depend on the slit width until you get past one surface, because the two patterns end up, doing their combining thing. The last part is key, because edge diffraction shouldn't depend on the other edge. Well, like I said, there's a difference between edge diffraction and edge interference. So again, we're back to the argument of what creates pattern and what doesn't have pattern. Single surfaces don't create pattern. More than one surface creates pattern. So pattern and diffraction are two different things. The diffraction happens from either circumstance. The pattern happens only when you have more than one surface fucking with each other. You can perform an additional idea. For the double slit, whatever happened to your idea of shooting the photons at only one of the slits? Well, again, I don't think it's practical, because how do you block them but putting another surface into the experiment? You get me? You can totally do that, actually, if the middle impediment is wide enough. Well, I know, but the problem is if the middle impediment is wide, then you get less pattern. As I pointed out, part of this has to do with the smaller the middle impediment, the more likely that the condition of this surface is going to be communicating with the condition of this surface. The wider you make it, the less likely this surface is communicating with this surface. So the more likely it is you end up with two single slits just superimposed on each other if you make it wider, because this surface won't be doing its I'm in between 10,000 volt thing anymore. It won't have any clue that that's what it's doing. It'll just see 5,000 and 5,000. There won't be any 10,000. Alright, you can totally do that actually if the middle impediment is wide enough. If the impediment is 0.5 millimeters, we've got to be a lot smaller than that to get a good pattern, or more, you can totally shoot the beam into one of the slits. Well, I don't know, the beam is at least a millimeter, so I don't really understand that. If your idea is correct, you should still see the double slit pattern even if the laser goes to only one of the slits. Well, again, you can't see the full pattern if the two patterns are in part superimposed on each other, so they're different, but when you put them on top of each other, they'll have the more complex appearance. This is totally feasible to do, actually. Well, we'll see. You mentioned that the double slick pattern is a bar pattern. I agree that it looks like a bar pattern. Okay, yes, we already did that. So I guess we're done. Ah, my goodness. I'll just see if there's anything else on the subject. So this guy says, kind of incoherent to my ears. Well, that's really interesting. Not. So what is energy really? Whatever. Pointless. Hent Coven. Oh, one of the Emendum trolls. Double shits experiments next. Well, useless comments is all you're capable of, huh? Alright, so this is an alternative explanation. Yes, that's right. They're alternative explanations. That's the whole point of the channel. The explanations given for the causes of the effects we see in the universe. Their explanations of dark matter and dark energy and bent space and wavitons and Copenhagen and many worlds and photons that can read your mind and Huygens and Heisenberg. It's all bullshit. That's right. Alright, so yeah, done. So sorry about the length of the video. I will try to make another video cutting it down a little bit. Sorry the comments weren't in the right position. I must have moved it for the web page or something. But anyway. So anyway, I'm just saying, so this dust thing was interesting, but I like the fact that it ties two things together. It ties together my argument previously that the diffraction gradient, or the half-silvered mirror, creates two very different beams, not the same beam, and it ties to the that stupid ferrocell, and it gives a more plausible explanation for what the ferrocell is doing. It's actually creating these ringed patterns, and they're just being distorted by the pressure of the fluid, the uneven pressure of the fluid. Alright, anyway, so until next time, and such. I think.